Hello everyone, welcome to my channel EC Point. Today I am going to discuss about MOSFET, metal oxide semiconductor field effect transistor. I will upload NOR gate, OR gate, XOR gate and XNOR gate using NPN transistor soon. From MOSFET, we know that MOSFET consists of 4 terminals: gate terminal, source terminal, drain terminal and substrate. Here you can see that this is a MOSFET. So, in case of NMOS, N-type MOSFET, in case of NMOS, substrate will be P-type substrate. Always remember that. In case of NMOS, substrate will be P-type, and in case of PMOS, substrate will be N-type. And S and D terminals are heavily doped. We know that in case of P-type semiconductor, what will happen? Minority carriers are electrons and holes are the majority carrier. When positive gate to source voltage is applied, then what will happen? The minority carrier present in P-type substrate gets attracted, minority carriers, electrons gets attracted, and the holes will get repulsed and it will be dropped here towards their ground point. So in this case, what will happen? Under the gate region, there will form a channel, negative channel, electron channel, right? So this is called the channel formation. Now, what do you mean by threshold voltage? VT. What do you mean by VT? Threshold voltage means a minimum amount of voltage that is needed to activate the MOS. The minimum amount of VGS get to source voltage in which the channel can be formed. So this is called VT, right? Now come to the main. So in this case, a uniform channel will be formed under the gate region. Now if we apply positive VDS, that means drain to source voltage, then what will happen? Come to this graphical representation. This is VDS and this is ID. Drain to source voltage and drain current. Then what will happen? ID will increase with the increment of VDS. After a certain period of time, it will remain constant. It will not increase with the increment of VDS. This point is called pinch-off point. That means at that point the channel get pinched off. What do you mean by pinch-off voltage? After going to pinch-off voltage, I will discuss what is channel length modulation. Now, this is an uniform channel. Then how will we can modulate the channel length? So if in this case, in saturation region, we know that VGS is greater than VT obviously, and VDS equals to VGS minus VT. So you can see that after a certain period of time, ID gets constant with the increment of VDS. So now what will happen? How can we calculate the effective voltage? The VDS after a saturation period, if we increase the amount of VDS, then what will happen? VDS will greater than VGS minus VT. Now we know that this is VGS and this is VDS. VGS work vertically and VDS work horizontally. So what will happen in this case? VDS is greater than VGS minus VT, right? So now if we write VGS minus VDS, then we know that VDS is VGS minus VT. Write down here VGS minus VT. What will get? VT. So VGS minus VDS equals to VT. That will get. So what will happen here? We know that current can pass through the device when the current direction of current flow is opposite to the direction of electron flow. Here electron pass through source to drain terminal, electron flow, and so current can flow from drain to source terminal, IDS, drain to source terminal, right? So now what will happen in this case? If we increase the amount of VDS, then what will happen? Then the channel length gets modulated. The uniform channel length. This is the uniform channel length, and it gets modulated. That means when we apply more VDS after the saturation period, then what will happen? Then this point is going to shift here, going to shift there, here. So what will happen? The length of the channel gets modulated. This way modulation is there. After more VDS, it will modulate there. So you can see that the channel length become lower than the original channel formation, and it will not remain in uniform state. So this is the channel length modulation, and you know that this is called the pinch off point. After this point, you can see that there is no connection between, no channel connection between S and D, source terminal and drain terminal. Then what will happen? Current flow will be stopped. So this is called the pinch off voltage. Pinch off voltage is amount of positive VDS voltage in that voltage, in which amount of voltage ID remains constant. ID remains constant after this amount of period. ID remains constant, and this is called the pinch off voltage. This is called the pinch off voltage. So this is the NMOS, working principle of NMOS. In my next video, I will discuss about PMOS, P-type MOSFET, metal oxide semiconductor field effect transistor. Then we will discuss about the basic difference between NMOS and PMOS. So you know that NMOS is faster than PMOS. Why is it? I will discuss it in my next video. So thank you so much. Thank you so much for watching my video. Like, share and subscribe.